Okay, we'll look at arithmetic on the number line, something that I believe is pretty much always taught in elementary school. But with the tendency to overuse calculators, people often lose track of what the arithmetic means, don't have a visual connection to the arithmetic. Just punch it into the calculator and accept what it tells you. Okay. Not everybody does it, but there's a tendency. Okay, so I'm going to create a number line here. And I'm going to take the number, well, let's say -8 here. Put 8 here. And then I'm going to divide that interval in half to get me 2. Divide this interval in half, tells me what 4 is. Divide this interval in half, tells me what -4 is. Divide this interval in half, and I get 6. Divide this interval in half, I get 2. This interval in half gives me -2. This interval in half gives me -6. And then, of course, I have my units in between. Okay, well, there's a perfectly good number line, at least from -8 to 8. Now, if I take an arrow starting at 0, and I'm going to put a dot on here. And this is where the arrow starts. It starts with a dot. And I'm going to have this arrow move over this far. The tip of the arrow is on 6. So the dot is on 0, the tip is on 6. We call this the initial point. We call this the terminal point of the arrow. And we also going to call the arrow a vector. Okay, so we've sketched a vector. With initial point 0 and terminal point 6. Okay, well, from this point, I'm going to sketch a vector, and I'm going to offset it a little bit. It's really supposed to be right on top of this vector. Of course, it's going to be a little harder to see what I'm doing if I put it right on top. So I'm going to go from here over here. Okay. Okay. The vector with initial point 0, the terminal point 6. I'm going to call it +6. I could get technical and put a little arrow over the top of it to indicate that it's represented by an arrow. Maybe I'll continue to do that. Okay, so here I have my arrow. Okay, +6 arrow. And then what is this arrow? What are you gonna call this arrow? Okay. Think about it. First, how long is it? That should be pretty obvious. You can kind of put the numbers. Okay, well, how long is 8? Is from 6 over to -2 is 1, 2, 3. Yep, kind of them. They're right. It's in the negative direction. Okay, so we'll call that arrow -8. Now, what arrow do we get if we start from the initial point of the +6 and move to the terminal point of a -8? Okay. What are we going to call that vector? Well, that vector is -2. So we can say that vector 6 plus the vector -8 is equal to the vector -2. Now, we don't really need vectors to do this. Okay, we can suppress the arrows. We have 6 plus -8 equals -2. And of course, 6 plus -8 is just like 6 minus 8 equals -2. And we should understand that without having to punch it into a calculator. Seems a little bit ridiculous to have to say it, but with the overuse of calculators in many mathematics classrooms, I think it has to be said. Okay, so there's a picture of addition that actually ends up being a subtraction. And the add vectors. Okay. Okay, the head is the arrow, the tail is the dot. So we started with the first vector. The second vector, the head next to the tail, the second vector, takes us over here. So this whole trip is equivalent to just starting here and ending here. So that +6 -8 gives you -2. That's a picture you should always carry with you when you're doing addition and subtraction. It's the meaning of the operation. There are other ways to interpret the meaning, but those are important ways. I'm debating about whether I want to say something. And right now, I'm going to say, okay. All right. Now that's addition. Okay, so why don't you take a minute? See if you can do the addition. We know that it's 5 plus 7 minus 8. Oh, what the heck? What's 5 plus 7? No. I'm sorry. Sorry for thinking while I'm doing this one. Let's do 3 plus 2 minus 11. See if you can draw that out. Sketch yourself. Interval from -8 to 8. Do some subdividing. And you don't have to watch me do this, just go ahead. Three plus 2 minus 12. Okay, well, Presumably you've either done it or you haven't. I hope you did. But we don't always have to start at 0, but what the heck? 0, 3. There's our +3 vector. And then +2. Yeah. Tail goes on the head of the previous vector, and we move over 2 units. There's our +2 vector. And then -11. Well, let's see, starting here. Got to move over 1, 2, 3, 5, 6, 7, 8, 9, 10, 11. Got to move all the way over to here. And what's the result of that? 2, a 3, and a 2, and a -11 is the same as just starting at 0. And doing a -6. Okay. So we come up with the conclusion that this is -6. Okay, now what does 4 times -3 mean? Well, I'm not going to sketch a number line and everything, but you understand how this could be sketched, or at least you will if I do this. It means I've got 4 -3s. Well, -3 could be represented by an arrow. Okay, clearly, if you're going to put units in this, you divide it into 3 units. You don't really need to do that. You just do 4 of them. And if you got a number line here, whatever this point is, total arrow is going to give you -12. If you drew it on the number line, counted 3 units in each one, of course, we understand that's what would happen. Okay. Now we've seen how to either represent addition or subtraction. Subtraction is being addition of a negative, or even to do multiplication. Now to go back to our 4x4 rectangle, put an x-axis here, y-axis here. And I'm going to draw a straight line. I'm going to draw a straight line here. This is a straight line segment from here to here. Now, what I want to do is I want to draw a set of points where every point of this segment is moved twice as far from the x-axis. So I'm going to take some representative points. Take this point and this point, this point, this point, this point. Okay, I want to move every point of each purple point twice as far the x-axis in the vertical direction. Every point needs to go in the vertical direction, excuse me, my nose is itching. Every point needs to go in the vertical direction. Twice as far from the x-axis. So just take a stab at it. I'm gonna, these points are more or less equally spaced. I'm gonna just put a point here. You can probably figure out what the coordinates of some of these points might be if you make reasonable assumptions. But let's not worry about coordinates. Let's just see, where is this point going to end up? How are you going to locate that point without resorting to use of numbers? Only number being 2, twice as far. What are you going to do? Can you use arrows? Well, yeah. Okay, so hopefully you thought about that. You got an idea in mind how you might use arrows to do this, or maybe you don't have an idea in mind. I'll put one there for you. Okay. This arrow represents how far this is from the x-axis, doesn't it? Because if you're going to get to the x-axis from here, you're going to go straight down. If you go at any other angle other than straight down, you're going to have to go further. Okay. If you want to just get to the x-axis, you're going to take the closest route. So that's how far this point is from the x-axis. Okay. Now, if I want to move each point twice as far from the x-axis, then I'm going to have to add this much to the y-coordinate, which means I'll draw another arrow. It's a vertical arrow because I did say move in the vertical direction. So there's another arrow the same length, and it ends up maybe right here. Okay, well, go ahead. You should have a sketch of this. You should be working on a sketch instead of sitting back comfortably, sipping the Coca-Cola and eating the baked potato chips or whatever. Okay, do this actively. If you don't have this picture here, you're not totally with the program. Now, maybe you can absorb it completely just in your imagination. If you draw it out, I think you're going to get it a lot better. Okay, well, anyway. Okay. So go ahead and do that for a series of points. You don't even have to have the same points that I've got. Okay, well, hopefully you've done that. Let's say for this point, well, here's your arrow. Obviously, this arrow is going to be shorter than this one. So the arrow that you add is going to be shorter than the one we added over here. Then, you know, we need to make a few corrections to it, but hopefully we've done that. And so here's this arrow. We've got to go that far up here. So this here. Here's an arrow. Now this ought to be easy. This is a line wide 2, and this is a 4 unit. So obviously, if I add an arrow of the same length, and if the thing has been, picture's been made correctly, it's going to go to this corner of the original box. This point will go up here. This point isn't going to go anywhere because it's on the x-axis. Twice as far from on it is still on it. Twice 0. Your distance is 0, twice 0 is 0. Then we can connect these points. And you can think about it, you should make a straight line. We could do the same thing with star graph. Do this inside my forward. Never do get it right. Okay. What's going to happen? I'll just take some points here, 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 here. Well, this is draw arrows. Here's an arrow. Here's an arrow of equal length. And do this yourself. Clean down. Done it yourself. If you're gonna look like this. I'm doing it kind of sloppy, kind of quickly. You get the idea. I guess I'm going to do this one. And then if I connect the tips, those arrows with a smooth curve. That smooth curve is going to look like this. It'll be a nice parabola. And that parabola is going to be inside of 4x8 box. That's all kind of sloppy, but you can see you get a color parabola. It looks skinnier, although it does have the same width. But at any given y value is going to be skinnier than the original parabola. Well, that's an important idea. So we can see a couple of things. This is a straight line. Both of the line don't. Parabola sort of looks skinnier and tall. Words of wisdom rated onto the board. It's important to picture. I get all my words. Okay. Okay. You should be able to do that. If I were to give you a graph, I'll just do one real quickly. I give you. Let's that at this point. Give you 4 points and ask you to sketch the graph and a function. Give those 4 points. There they are. Then if I ask you to, let's not double it, let's halve it. Let's take half. Okay. Take each of these points. And then take a point that's halfway to the x-axis. And now I have a point here, 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 and here, so that doubling coordinates of this point, and this point, this point gives us our original graph. We can then sketch those points. You might or might not understand at this point why that's important, but that's a very important thing you can do. And the thing to understand is the further the point is from the x-axis, the further it's going to move. Okay,